माइक बंद कर दीजिए वहाँ से फिलहाल।
यूट्यूब का ना।
Yes, I'm ready.
Yeah, very good evening, sir.
Yeah, good evening to everyone.
Yeah, this side Assistant Professor Rita Kradam from Department of CSE AI DS. Welcome you all once again to day 3 webinar on India Idea to Deployment AI Project Bootcamp. The last 2 days have been full of learning with our speakers sharing practical insights on how to take an idea and turn it into a real project. I am sure each one of us has gained valuable knowledge that will help us in our academic and professional journey. Today we continue this journey with another our special guest, Mr. Mahesh Kanote sir. Before we proceeding, I would like to call our HOD, Mr. Pande sir, to share their thoughts. Please, sir.
Yeah, thank you so much, ma'am. First of all, I would like to welcome all of the participants who are regularly attending the session. Glad to see your overwhelming response for this webinar series. Definitely, this bootcamp series will help all the participants to gain knowledge and insight regarding not only artificial intelligence but also how to make it deploy on the cloud. Today's topic is very interesting, where Sir will be discussing regarding unlocking the cloud universe with multi-cloud storage strategy. And yes, indeed, it is the need of the hour. So, on the behalf of artificial intelligence, data science, and artificial intelligence machine learning, I would like to welcome Sir, Mr. Mahesh Kanote, Sir. Definitely, your session will help our student to gain more insightful information about cloud technology and observant strategies that will not only inspire them but equip them with the insight of the uh, data which they will not be able to grasp through the textbooks. So your industry experience will definitely help them in the same aspect. And I take this opportunity to thank the organizer, the event coordinator, Ms. Rita Kadam madam and Ms. Tanuja Pande madam for organizing such kind of event. Looking forward to the series. Thank you so much, sir. Over to you, ma'am.
Yes, sir. Thank you so much, sir. Now it's time to move to the most awaited part of today's program, hearing from our distinguished guest speaker, Mr. Mahesh Kanote sir, who is a senior technical professional with over 18 years of experience in the software development, architecture, and leadership. He has worked across different industries including fintech, IoT, e-commerce, and cloud solutions. Currently, he is serving as engineering technical leader as SplunkApp Dynamics, part of Cisco, where he leads teams in building large-scale enterprise applications and driving innovations in observability and monitoring solutions. Mr. Kanote is not only an expert in technologies like Java, Python, Golang, cloud, and DevOps tools, but also a mentor who has guided teams to achieve excellence. He has contributed to patented innovations in IoT and systematic monitoring, which shows his passion for research and problem solving. We are truly honored to have him with us today. Ladies and gentlemen, students, please join me in welcoming Mr. Mahesh Kanote, sir. We kindly request you address the gathering, sir. Over to you.
Okay, so thank you everyone. Thanks for a great introduction, and I'm very happy to have this opportunity to present myself and some of the work which we do day to day. Hopefully, you find it helpful and useful in your future. So let's get into the topic. Let me share my screen. Okay, so can you guys see my screen, all of you?
Yeah, sir, it's visible.
And it is properly zoomed, right? There is no problem in.
Yes, sir.
Okay. Okay, just give me 1 minute. I'm just trying to adjust my screen.
Sure, sir.
Yeah, just there is some problem. 1 minute. Okay. Now can you see my screen?
Yeah, sir, it's visible.
Okay. Okay. Sorry for the delay. So let's discuss about the multi-cloud strategies and intelligent observability. So basically, we will be covering how the cloud universe is helping the companies to build the feature faster and ship it to the market. But at the same time, these cloud providers brings in the complexity. Reason being, there is no single cloud in the today's world. There are multiple cloud providers in the market like AWS, Oracle, Azure, GCP. So all of these cloud providers have the presence across the planet, and how it creates the complexity for the companies, and where does the observability or the intelligent observability comes in the picture. Let's talk about that. So overall, this is our agenda. We will first talk about this day zero architecture. That means how companies were building the big infrastructure and their workloads on the like you can say 20, 30 years back, and when the multi-cloud was not there. After that, when the multi-cloud was born, how it has benefited the companies. And even after the multi-cloud has come, what are the challenges with the multi-cloud also. We'll take a deep dive into that. And after that, we'll discuss about the container technologies and what is the importance of the containers technologies. And now, since we have brought in the container technologies, we need something else to manage the containers. So that is where the Kubernetes orchestration comes in the picture. I will cover the details later. And now, once we get into a place where we have the container orchestration and how the infrastructure becomes so complex for the companies to monitor and see what is happening with their workloads in the real time, that is where the observability and monitoring comes in picture. And in that, we will cover EVM, APM, and AI for observability in detail. So with that, let's get into our first topic, the day zero architecture. Now, in the past, what has happened is when companies have built applications, Essentially, those were getting built as a monolith application, meaning a single big application, heavy application, which was running on a physical server, which was completely managed by the IT operations team of the companies. Meaning, the company has to think about the real estate required for those data centers, where they will install those data centers, right? And how to make sure those data centers are maintained properly. I mean, for each data center, we have to make sure there is enough power storage. Apart from that, there is a cooling mechanism which is also required. So all these things company used to manage in the past. Now let's say they have installed one data center. Now we want to scale it, right? Now imagine a today's world where we are using that. I know most of you must be using either Amazon.com or Flipkart.com or Mintra.com, as we are in India. So you can relate to one of these websites, and all of you know there is a big $1 billion sale which happens on each of these websites, right? Now imagine companies are managing their own data center in their own real estate, meaning in their own building, and all of a sudden the $1 billion sale is coming and the huge traffic is gonna come. Now that data center doesn't have the enough resources. So what will happen? The next step for for that IT operations team is to procure the hardware, meaning they have to provision the hardware, right? And which is a long and manual process. Even if you plan ahead, let's say 6 months ahead, I'm gonna do a big $1 billion sell. Let's say they were proactive and they have actually brought in a lot of hardware and they have set up one more data center. Now there are two data centers, right? But now the challenge is, in a year maximum there will be one or two what you say, the $1 billion cells, or the traffic will hit. Now remaining time, right, that those data center or the newly installed data center is completely unused. So what is the problem here? The problem is the cost. Now even after paying so much, it is just used for one, maximum 1 to 3 or 5 days. After that, company is unnecessarily paying for, and it's a liability. They have to make sure until the next $1 billion sale hits, we have to maintain this all hardware. So that is a problem with this day zero architecture. And there are siloed, it creates basically a siloed amongst the team, like the development team, operations teams, and the network team. The other challenge is the manual deployment and rollback. So these are some of the challenges, like slow to innovate. Essentially, it will take a lot of time to procure the hardware, install it, and then it slows down the whole process of hitting the market faster. And poor utilization of the resources, which we just talked about. And also it's a single point of failure. Now if some natural calamity happens, right, and let's say that organization is in Pune or in Bangalore, one of the places, if there is a natural calamity and because of that, that in that city there is a power outage or there can be water clog, anything can happen, right? Considering all those scenarios, there is a single point of failure. And what if there is a problem in Asia region itself, right? So how do we tackle these situations? And the cost we just talked about, because just for 5 days I need a whole infrastructure, but now I have to scale down. Now to scale down, it's not easy to scale down the hardware. So that's where, so this is a day zero architecture. In a company headquarter, you will see one data center, which we talked about. And later for scaling, we would have added one more data center. But what if we need one more, right? Now, how do we basically elastically scale up and scale down, or scale out or scale in? So those capabilities we will not get unless we have a elasticity in our architecture. So this is like in one data center, you can see this is how it looks. Basically, a server is running, let's say server 1, server 2, and server 3, and each of these servers we are running the application. So this is how the traditionally it has been. And the challenge is elasticity. We are missing the elasticity here, because once we have the elasticity, we will save on the cost. We'll save on many more things actually. So let's get into now understanding why should we use the cloud. So the first thing is it reduces the time to the market, meaning the companies can now ship at a very faster rate, because there is a huge competition in the market. It is very important we scale fast, we ship fast. Dynamic scaling, as we discussed, so we need a way, our architecture must be scalable architecture. We should be able to control at what time, at what day, and when we want to scale up or scale down, or scale in or scale out. Another important thing what cloud providers provide is, let's say we have a particular virtual machine which is running in our data center, but we do not know whether either we can buy or create a virtual machine which is CPU optimized or optimized for memory workloads, or there can be some special purpose built VMs also. So these are the capabilities cloud provides. Essentially, they have an inventory of VMs which can align with your type of the workload, which needs a CPU optimized. Probably it needs more CPU than a memory, or it needs more memory than a CPU. And there are purpose built VMs as well, a general purpose as well. So this is the biggest advantage. Also, the core part of any application is a database. It's very important, and we always make sure databases are running 24 or 7, 365 days. Now, if we don't have a cloud provider in our own data center, what will happen is we have to basically do the administration of the database instances. We have to make sure those database instances are highly available, making sure they are scalable, they are performing at their peak, they are optimized, and as and when we have to scale, we are able to. So basically, we need a team which can just manage the infrastructure of the database. So that is where the cloud shines here in that case, because cloud has managed database services. I will cover in the next section what are those managed service database services. But essentially, you are delegating the whole management of the databases to a cloud. So as a company, or let's say I'm a startup, right, starting new, or even enterprise companies, right, like even we use the cloud. We don't have to worry about whether the DB instance will go down or how the infrastructure will scale. We have delegated all that to cloud, and in no time we are able to provision an highly scalable database across multiple regions. Coming to the vendor lock-in, right? This is bit what you say, like the way we have discussed in the zero-day architecture. This cost is a big problem. Any business, the important thing is cost. So we have to make sure we are paying for what we are using. So that is the advantage we get with the cloud. And vendor lock-in meaning, like on the on-prem, right, to install those data centers and all, we will be tied up with few vendors, and whatever price model they will say, you have to go with it, because it is not a simple thing to replace immediately a data center with something else. So to avoid that cost, that's where the cloud comes in picture, and we pay for what we use for. Coming to the increased redundancy and disaster recovery, across the planet, all of this. So even if a particular region goes down, we have the ability to serve our customers from the different region. So there is an automatic failure which can happen, and there is basically a zero downtime for the customers. Disaster recovery, if in our traditional way, we have to build the DR mechanism, meaning we have to make sure the backups and the restores of such a highly critical workloads. Imagine bank, HSBC Bank or any bank, ICICI, SBI, or any healthcare institution, all of their data is very crucial, which we are saving in our data stores, right? Now, if we have not properly backed up, or we don't have a proper recovery mechanism, we will get in a situation where we will have a data loss, and which is not a good sign, right? So to avoid all these things, cloud providers have already built in disaster recovery mechanisms, also backup and restore capabilities. Geographical reach, let's say, now let's take an example of one of the company which is in India. Let's take an example of Lenskart, right? I have worked for the Lenskart, so I will take the name of the Lenskart. So Lenskart, when it started, their operations, or you must have seen a lot of their shops, outlets, they're selling only, we were selling the eyeglasses or sunglasses only in India. And in last few years, Lenskart has gone out of India, right? Now imagine Lenskart running their workloads in India on their own data center, right? Which is managed by them. And all of a sudden they started selling in Singapore, US region. So there will be a lot of latency for the customers who are using Lenskart app or Lenskart website to purchase the glasses from US region or an Australia region. the advantage with cloud is the geographic regions. Immediately, we can basically use their region which is out of the box available and start running our workloads. If we have a plan to expand our customer base or user base, so it comes very handy. Actually, we can deliver very fast. And as we talked about the cost optimization, we only pay for what we use. So that's the biggest advantage. So typically, this is how there are two models, hybrid and multi-cloud. We'll focus first on the public cloud, and I will explain the hybrid cloud in a minute. So on the right-hand side, you can see here is your application. Somebody is accessing on a laptop or a desktop or a mobile app, right? Your application is deployed in any of the public clouds which are available in the market, right? Now, from there, they can basically access your website and it is highly available. So generally, a lot of companies are, you can say, only using the public cloud. But if you take the other scenario where, which are financial institutions, right? The data or the customer information is very, very, very crucial. That is where the hybrid cloud has born, basically. So in that, what happens is customer still maintains a portion of the private cloud where the secure data, which is very important piece of the data, is still kept into the private cloud. But the things which can be made public, those are still running in a public cloud, and there is a very secure line which is built between a public and a private cloud. So this is where the hybrid has born, because it depends on the what you say, the customer are, which audience you are trying to serve, and what are the regulations which are followed in that country. Just to give an example, in Europe, there are very stricter guidelines when we are trying to capture or running any website. They literally, I mean, we have to make sure we are not tracking any information which is personally identified information. We have to follow other GDPR compliances. So it depends on those legalities as well. It's very important. So that's where the hybrid cloud comes in picture. Now let's look at some of the top. There are many cloud providers, but we'll just focus on top three, or rather three: AWS, Azure, and GCP. AWS is an Amazon Web Service, right? And in terms of compute, you might be using Windows or Linux or Ubuntu, right? Those are the OSs we generally use in our laptop or a desktop, right? Like that, similarly, AWS Cloud provides their own compute, like Elastic Compute Cloud, that is called as EC2. And they also provide a compute called as Lambda. It can run dynamically. They also have Elastic Container Service and Elastic Kubernetes Service. Similarly, Azure has its own computes, they call it VMs, and the replacement or the equivalent of Lambda in AWS in Azure is functions. EKS, it is again, it's an Elastic Kubernetes service. Here we call it as Azure Kubernetes service, and they are their own container instances. Similarly, GCP has its own compute engine, and GKE is again a Google managed Kubernetes service. So look at it as these are some of the services these companies have Kubernetes. And for AI/ML also, they provide their services. Just look at the real biggest advantage. If you want to run an AI or ML related workloads in AWS, so Bedrock and SageMaker, these are the services you have to provision. We can just follow their document or take their support to provision these Bedrock and SageMaker. Similarly, Azure also has their own AI/ML services. And storage, in terms of storage, this is like a elastic storage. The S3 is like a service where you can save the binary data, which is a blob data. Essentially, it's an file storage or an object storage where we can save video files, audio files, or even the static web pages. It basically is a very highly available service. They basically claim it to be like close to, I think, six nines, if I'm not wrong, percent availability. So these are the storages, meaning a disk, you can say, this EBS, EFS, elastic blob storage, elastic file storage. And similarly, Azure has its own files, data lake. Now coming to the databases, right? So this is what I was talking about. Now, if I want to run an Oracle DB or MySQL DB, AWS has this RDS service using which we can run a completely fully managed database by AWS. We don't have to worry about any administration. This is a what you say relational database. This service is for relational database service. And if we want to use, let's say, we know our data type based on the type of data we are storing, it's a key value pair, right? Mostly, then we can use a DynamoDB. Now this is the database which is fully developed by Amazon or AWS, and in no time we can actually start using it. It's very simple to use. But yes, every technology has its own pros and cons. We have to decide based on our use case what we want to use, whether I need a key value pair, or I should, or my data is mostly a relational database, or I need a very stronger consistency or a transactional guarantees. That is where I will go for relational databases. If I'm okay with the eventual consistency model, then I will go with the key value store or document store, that is a DynamoDB. And the equivalent of DynamoDB in Azure is a Cosmos DB, and similarly in what is in Google GCP we have Cloud SQL, Firestore, and Bigtables. So these are some of the services they provide. Let's I will just I will cover one cloud architecture in detail. Let's talk about the AWS. Now AWS, if we see their global infrastructure, there are close to 120 availability zones. They have 38 geographies they are already in, and they are planning to actually add more. Now these are some of the high level regions they have. In each region they have what you say the these are yeah, okay, let me just go to this link 1 minute. So you can still see my screen, right? Okay, so in Asia, right, we can see in Asia Pacific, AWS has a data center in Mumbai, right, and in Hyderabad also. So similarly, in each region, let's say if we go to South America, so this is where in Sao Paulo they again have a data center. So like this, they in each, like in Europe, right, so many places they have the data center. So if I have to expand my business across the world anywhere, they have the infrastructure already provisioned, so we can start using it in no time. So that's the biggest advantage we get with the cloud. I will go back to my slideshow. Yeah. Now let's say we 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 register with AWS and we have our own AWS account. This is how their global infrastructure looks. You can see here are the users. So this is North Virginia region. You can see this blue line. This is a boundary of a region. Now imagine you have registered with the AWS. You have an AWS account. You can go to a particular region. You can think of it as a Bombay also or Hyderabad also. And in that we can create a VPC, which is a virtual private cloud. It's a stricter boundary. Any resources like virtual machines, internet gateway, NAT gateway, subnets, or your any workloads, anything we are creating in that VPC, it is not visible to anyone. It is your private, what you say, private real estate. Nobody can enter unless you have given a permission to enter. So that's how the cloud provider provides the isolation between the customers. Remember, in same region, there can be a lot of other customers which have the AWS account and they will create their own VPCs. So the cloud infrastructure is heavily provisioned and multiple customers even can stay in the same region, at the same time maintaining the isolation. They do not know each other and their data is not shared at all. Those are the guarantees cloud provides. And you can see here there is one more region we are demonstrating, Tokyo. Imagine this as a Bombay or Hyderabad again. There are, let's say, two regions. This is Hyderabad, this is Mumbai, and we can also have a connectivity between them. And this is a AWS global network, because if if there are services which want to interact between across the regions, right? If they start going through the public internet, the latency will increase all of a sudden, and that is a red flag. We want our services to be fast enough. So what AWS has done is they have put their own global network. So the traffic between the regions goes from their network. So the latency has drastically reduced here. One more thing you can see in the diagram is edge locations, right? So what are edge locations? We already have a, let's say, Bombay region and uh, Hyderabad region. So what is the edge location? Imagine somebody who is in Assam, right? He is trying to access uh, a data which is stored in a data center which is in Mumbai or Hyderabad, and that data is kind of a Netflix video or a YouTube video. So the amount of time it will take to download even on the person who is using in Assam will be more compared to the person who is using or trying to access the same video in Mumbai or Hyderabad. Now, how do we reduce that, right? To reduce that, there is one more thing which AWS has built, that is called as edge locations. Essentially, it's a, you can say, macro version of a data center which is running in that particular city or in that state somewhere, and any static content like videos, images, or any static files, it caches for a certain amount of time. So that is why then if we have that level of a caching, so for very first user, when the request comes here, if edge location says I don't have this file, I don't have this data, it forwards it to the actual region that is nothing but its origin or a source, and it then downloads and keeps it here. Now any new user, or there are hundreds of users which are accessing, they will receive the data from the edge location. So the whole round trip has been avoided for such uh, files. So that's the advantage, and we see data coming very faster. In case of Netflix, if you see, they are almost doing they are on AWS, and they are using the same, mostly same architecture, and they have gone next level also. They actually use they run their what you say, not run, actually they cache their videos onto ISP, if I'm not wrong, in internet service providers servers as well. Now in this we can also see there is an on-prem data center which I was talking about. Let's say there is a bank, right, and they have few workloads running on public cloud, and some of them are running on on-prem. So this is where the connectivity, we can use AWS Direct Connect, or there are other ways to do that also, the connectivity, but this is a private connection. It is not going through the public internet. So that is the advantage, or this is the high level overview of AWS global infrastructure. Now, if we get inside this VPC, right, now what is there inside this VPC? Let's talk in detail. So in AWS cloud, you can imagine the outer box is AWS cloud, and the green box is a virtual private cloud. It's a very private cloud. It's a virtual boundary which is created. In that, we will have the availability zone A and availability zone B. So these are, you can say, two different, totally physically isolated data centers in that particular region. And we have to make sure for high availability, our workloads are running in availability zone A and availability zone B. In case the availability zone A goes down for whatever reason in that region, via using availability zone B, we are able to serve the customers. So that's the biggest advantage we get with the availability zone. So if you just draw a mind map of this, we have an AWS cloud. In that cloud, we have a region, and in each region, we have minimum three availability zones. So it is highly available, or with three available big servers, you can say, in very, very simple terminology. Even if one server goes down, the AWS server, the other two are capable of handling our load. Now, in that availability zone as well, we can segregate our workloads, because some of the workloads might be very important, meaning the database, as I said, and it has a crucial piece of information, which is data for the banks. We can actually make sure those are running in a private subnet. So essentially, the point I'm trying to make is We can have next level of segregation as well. We can say I want to run this particular workload even in this availability zone into a public subnet or a private subnet. So anything which is in private subnet, it is not reachable from the internet at all. It is completely isolated. So that's the big advantage we get. And there are gateways like NAT gateways, internet gateways, which are used to communicate between them. Now, the now since we have completed the cloud and in their infrastructure, and we have talked about the VMs as well, which are EC2 machines which are provided by AWS. The challenge now, let's go back to our original example of an e-commerce website and the $1 billion sale is coming. Even though we are in a cloud now, what will happen with this is if we don't have a, let's say, container technology, right? And the next topic is the container technologies. The challenge is, let's say we have a product service, card service, uh, order service, and a payment service, right? Lot of traffic will hit on the search, right, on that day and add to cart. Now, if we want to scale, as cloud has a capability to scale dynamically, maybe we need, let's say, 1000 instances of card service, right? The challenge here is it spins a full virtual machine. Now, when we talk about a virtual machine, the when we are spinning a virtual machine, essentially it runs its own guest OS. The moment it runs a guest OS, it has to basically load all the binaries, all the packages, all the configs, and the size of that image, right? The this meaning the whole image size of that VM will be bigger, and it needs more CPU, more memory. So even if the load is coming very fast, the boot time of the VM itself is more. So until it boots, you cannot serve the traffic. So and if that time is, let's say, 1 minute, 2 minute, or 3 minute also, or 5 minute is very long time, or even 3 minute, whoever I was trying to reach out to the website during that time, all the requests will be lost. So that is a big problem, and we need something which is lightweight, which can spin very fast, but at the same time it maintains the isolation, meaning same like what we have in our what virtual machines provide. So to do that, that is where the container technology has born. It is portable, and it provides the isolation, and it is highly efficient because it needs only very minimal things to build a container. We don't need everything what a particular OS has, and it relies on the host machine OS kernel. And these technologies are built on namespaces and C groups. If you have heard about in the Linux also, we do the same thing. As we already have these C groups and namespaces. That's how the resources are provisioned to any process which is running in your machine. So it's the same concept, and that provides the isolation. So in a nutshell, this is the difference we have with with VMs. We need an hypervisor. These are heavyweights. Mostly their sizes will be in GBs, but containers are in MBs. But container also needs a runtime. I will talk about the runtime soon. And these are slow to spin, and these are faster. So this is the main reason container technology has born, because we want our workloads to serve the user request faster, and we don't want to lose any user request. So at a high level, this is how the architecture is. In the old days, on the left hand side, we can see virtual machines, how they were spinning. Basically, we had an infrastructure. On that, we need a hypervisor, and hypervisor is you can say a simple words. It's a software on which you can launch the guest OS. So this is how the guest OS or a VM which is using a guest OS will be launched. It has its own bin libs, binaries, and libraries actually, and the app 1, app 2s are running on them. But with the container, you can see the hypervisor layer is completely gone. We are relying on the host operating machine, and we install a container engine on which we can just build our Docker containers and run. Like app 1 has one Docker container, app 2 has its own Docker container, app 3 has its own Docker container, and all of these are isolated even though they are running in one operating system. So that's the big advantage. if you install the Docker in your local, you can install that as well. This is how you can these are the commands you will use in from your local. And this is how, in since we installing in our local machine, the client also is running in our local machine, and the host is your host basically, that acts as a Docker host. And there are registries, Docker registries. I will show at the end what are those Docker registries. From so basically, Docker registries are the public registries where the MySQL image, Oracle image, or any other images which are out of the box available. Now imagine you installing a MySQL in your machine or Oracle, how much time it will take. Rather, what I will do, I will just say Docker pull MySQL. I actually I'm ready to use a MySQL in no time. So that's the big advantage we get. So if you see, I'm not sure how much time I have, but I have my Docker running in my local, right? So this is Docker pull MySQL Oracle. So this is a command which I will use, right? And it pulls a Docker from Docker Hub, Docker image for MySQL. Since I already pulled, it is saying you already have it. Yeah. So 1 minute, I will just show you Docker Hub. Yeah. So this is the Docker Hub. Oh my God, it is taking a lot of time. Okay, it is taking the time. I mean, I will show you after some time once it loads. Yeah, so this is how out of the box let's say I want to install some Jenkins server, which is responsible for building and deploying the workloads. In a traditional way, I have to understand how to install a Jenkins, but with this Docker container, I can simply ask the Docker Hub using the Docker command, can you pull this image for me, Jenkins image? And in no time, I'm ready with the Jenkins. So that's the advantage. And container runtimes, Docker is not the only container runtime. There are other container runtimes like Containerd, Cryo, Podman, Runc. There are many actually. Now imagine we are running thousands of containers, no matter which container runtime you are using. The problem is who will manage those containers now. Earlier, the VMs were managed by the providers, the vendors. Now, who will manage this Docker container? Let's say we are running 1,000 instances of card service, as I said, or a product service. How do we make sure the load is getting balanced? Where is the load balancing happening? Who will make sure we can provision the resources like CPU, memory, and some security guidelines? So that is where the container technologies are born, and the container orchestrator, the container orchestrator which is provided by AWS is called as Elastic Container Service. Using this also we can run Docker containers or Containerd, any of this. But the problem with AWS ECS, it is a good orchestrator, we can use it, but the is if we start writing all the syntaxes using Elastic Container Service, which is defined by AWS, tomorrow if we want to scale the same work, install the same workload in the Azure or GCP, this syntaxing will not work because Azure has its own container technology and GCP has its own container technology. So we are still having some level of the vendor lock-in. Now, how do we avoid that and make sure we have a very generic solution which can work in any of the cloud? We don't have to worry about separate syntax for each cloud. That's where the Kubernetes comes in picture. We can actually build the Kubernetes infrastructure and start using the standard Kubernetes syntax, which is defined by the Kubernetes or CNCF community. So using that, once we start building, we can deploy our workloads as if it was running in AWS, Azure, and GCP. It's exactly same. And there are other container orchestrators like OpenShift, Docker Swarm, and Nomad. This is a very, very, very like 50,000 feet view of in Kubernetes. It has a clustered architecture. It has production patterns, security, and governance. It helps in container deployments, scaling, managing them across the clusters, hosts. It also has the self-healing capability and load balancing. It has the architecture basically basically is it has its own master terminology. So this is a control plane. Control plane itself has many services, API server, scheduler server, that is called, and they have their own database called as etcd. So this is where you can see it's an etcd, and controller, they have their own controller. And this is where the worker node meaning this is where the actual product service, card service, order service, or payment service, monitor service, all of these will run on the worker node. And if I need a one more node, it is the responsibility of a Kubernetes, sorry, not Kubernetes, but the cloud provider. We can configure the auto scaling group. It will scale the node. And if I need to scale the parts, that Kubernetes will take care based on the configuration we provide. Now, given all of this, right, in today's world, we can see the architecture has become very complex. It is spanned across multiple clouds. Even in one cloud, we have multiple regions, and in one region, we have multiple ACs. And imagine a company which is running all their workloads in all the environments, right? Now, how do you make sure that all these workloads are getting monitored? Because it's too many servers to manage. How do I know how much CPU utilization, memory utilization, which service is going down, which API is going down, how many API requests are coming to my particular API, where is the throttle which is happening in my database calls, which queries are slower, if I'm using any messaging queues, Kafka, ActiveMQ, where is the delay, right? How do we understand, even if we know this page is loading very slow, how do we know what exactly is creating a problem in my page? Because page has many components, right? It can have an Ajax call, it can have an image, it can have iframes, it can have CSS, fonts. There are many things in one single browser page. How do we pinpoint and say this is exactly is creating the problem? So, and if there is a backend service which is running, how do we know which particular piece of code is creating a problem, or it is resulting into the out of memory issues or null pointer exceptions? And how do we correlate this page is becoming slow, has no, we can pinpoint and exactly say no, there is no issue in an UI code, but actually there is an issue in the backend code. So how do we do this correlation? So it becomes very important for the companies to have the observability and monitoring. So that is where the observability and monitoring is born. The difference between them is, in monitoring, we generally just monitor and say, okay, this is my CPU utilization, this is my memory utilization, but it never tells you why let's say my CPU has spiked to 90%, right? All of a sudden from 60% to 90%, or my memory has spiked, or my latency has spiked. It will never tell you why it is happening. That's where the observability comes in picture, and it tells you this is the exact root cause why your resources are highly utilized or less utilized. So in very simple words, monitoring is very reactive, meaning alert comes and then you react. So which is a problematic situation for any real customers. Rather they want to catch the issues before they happens. That's the whole purpose, and avoid the downtime or customer or user dissatisfaction. So, but observability is a very proactive. It is based on the available data which is in the system. The system reacts, and it also forecasts what issues can happen. So that is the difference between monitoring and observability. In case you are confused why we use alternatively these two words, and like questions answered in very simple word, you can just say, is the system working, is what monitoring says, but observability says, why is the system not working as expected? That's important. And observability has two parts very broadly at very high level: end user monitoring and application performance monitoring. In end user monitoring, there are two aspects: real user monitoring and synthetic user monitoring. Now, I will come to core web vitals and geographic performance later. The real user monitoring, when we say, that means a user, let's say, who is accessing an Amazon.com website or an app, mobile app, right, in real, and or a Flipkart.com app or Flipkart.com website, he is a real user who is trying to hit that or use that website or a mobile app. And we want to monitor what exactly is happening at the user end. So that is where the end user monitoring comes in picture. So real user monitoring also has two things: browser real user monitoring, mobile real user monitoring. Now, there is still one problem with this real user monitoring, right? Meaning one caveat you say or a hidden thing. Let's say if $1 billion sale is coming and even if the sale is not there, right? How do you proactively know the issue is going to happen on this page? Because unless a real user hits that page, we would not know whether the issue is there in that page or the latencies are high or the load time is high on that page. So real user has to access either that app or that website. So that is where the synthetic monitoring is born. Basically, there is an ability for a customer. They can automate the real user monitoring workflow. You see, that's why it is called as synthetically, meaning simulating the real user behavior. So essentially, they will write some scripts and using that, they can simulate the user behavior, meaning customer is able to access the search page, then he's adding the product to the cart and making the payment and the order happens. And they can schedule and say, I want to run this automation every 5 minutes, every 10 minutes. They can decide the frequency or on the weekend. So any issue, and parallelly imagine the releases are going from the development team. So any issue which happens in the production, synthetic monitoring will catch proactively. So that is why it is called as a proactive monitoring or proactive testing. Core web vitals and performance metrics is what these agents will emit, meaning the real user monitoring agents and synthetic monitoring agents. These are very crucial because the rankings of the Google ranks them based on the core web vitals metrics. Yeah, and I will show the geographic performance distribution in the next slide. And let's talk about the application performance monitoring. So essentially, if you divide this into end user monitoring application, you can say end user monitoring is front end monitoring in very, very simple words. And application performance monitoring is a back end monitoring, meaning I have a card service which is running and I have few databases, few messaging queues, or you're talking to some third party for payment like Razorpay or something else. So that comes under the application performance monitoring. So if I put everything into the diagram in very simple words, so this is where the end user is who is using a browser or a web to access your website, and there is an end user who is using a mobile or an iPad to access the services which are provided by Amazon or Flipkart. And this is the company network. Imagine this is an Amazon network. So they have the backend services which are running, and these are also monitored by the APM agents, meaning let's say this is a Java service, this is a Golang service, right? Observability platforms have the exclusive, proprietary agents which are built for monitoring the Java services. They run as a part of a Java service, and here they run as a part of a Golang service. And if this is a MySQL database, we also have an agent which runs with the database process. So all the data, which is whatever is happening in this service, is available in our monitoring portal. So if the request is originating from end user, be from mobile or browser, it goes through the public internet and hits the company network. And anything happening here will be tracked by any exceptions out of memory, null pointer, no matter what exception is coming. It is tracked by these agents which are all running along with the process. But the problem is, and we can get the logs of this, right? Because these are running in the company network. But imagine users like us who are using our own laptop or mobile, and that app is crashing or that browser, somehow that website is not loading. How does the Amazon or Flipkart knows there is a problem? And they cannot ask for the logs, right? That's not possible. So that is where these agents which we have built or any observability platform would have built, that browser agent and mobile agents, which are instrumentation agent, which runs as a part of a browser. When you open a page, it starts emitting the events to the monitoring or the observability platform. So that this is how we are able to correlate between a page and an APM, and we are able to provide the end-to-end monitoring, meaning the point the request originates, when the page starts loading, essentially what happens in a browser is it creates the DOM, right? The very first thing is, and how, at what time the first byte has been received, even that level of information we have available. So end to end, we can clearly see what has happened. So in this piece also, there is one part which is still missing, right? That for end to end. Now this part is covered, what is happening from front end and back end. And even these calls which are going to the external services are also covered up to some extent. But what about the public internet, right? How do we know there is no problem in our website, meaning the front end code and the back end code, but there is still a problem that the page is loading slower? How do we know this is because of the public internet, meaning the network latency, packet loss, or jitter? So even we have some network agents which are capable of monitoring the network health and from which router switches the information is flowing. It can gather that information synthetically. It's not a real time, synthetically, but we can still do a correlation between like this is the page, card page I'm opening. What was the network latency, packet loss, and jitter at that time, and what was my backend response? So end to end, now customer can have a visibility across all the clouds or even a private network or on-prem data center. This is where the observability and monitoring is helping them to quickly resolve the issues, and they can also set up the alerts if required. So that covers the why we need the observability and monitoring. Now I will cover AI in the context of observability and monitoring. So currently, you might have seen, right? There are many LLM models which are available, right, today. Essentially, if you go to this website, while we are talking, there are 515 models which are available for text, 123 for images, and 41 for file, and 9 for audio. So these are the models which are available currently while we are talking, right? And you can also see the rankings. Like you can see for Cloud Sonnet, 602 billion tokens are used. And for number one, you can see the Grok code fast one, 1.5 trillion tokens are used. This is the real data. And Gemini 2.5324, right? Now the point I'm trying to make is there are many LLM models which are available, right? Now how do we make sure, uh, now let's say, like, let's take an example of Amazon or Flipkart only, and they are running, they are using all the LLM, all the LLM models. And see, it's not like Amazon has only e-commerce website, right? They might be having a lot of their internal projects also or services also, right? Now, how do we make sure, like, which application is using how many tokens? Because if you see the pricing model of a particular LLM provider, it talks about the number of tokens you consume. That's how the subscription model is, right? Now we as a company, I want to know which team, which department in my company is using more number of tokens. Which application is the product service using the more LLM tokens, or the card service or the payment service? I'm just making an example here. But to do that level and to run an LLM, this is a large language model, we don't use CPUs, right? We have to use the GPUs because they are purpose built for LLM, for complex things, and graphic processing unit is what we say. So that is where the LLM observability is very important. We want to understand what is the latency of that LLM model, what are the error rates, uh, and how can we manage the cost. So those are the places where we use the LLM observability. Now, few examples are here, like GPU and vector DB monitoring. LLM models used by organization, maybe one to many they are using, which team is using how many tokens, and intelligent alerting, and purpose-built MCP servers, model context protocol. So these are some of the things which are currently we are using, exploring, and this is an evolving situation. And the AI basically is helping us to monitor this. So there are two things in observability for AI. One is AI for observability, and another thing is observability for AI. So we are talking about here both. Okay. The use cases, the advantage is we can proactively do incident detection, reduce the noise and alert fatigue because we will send the alert when it is really required, improve scalability, and mean time to resolution. We go to the next slide. Yeah, so this is the dashboard, high level dashboard. You can see this is how it looks. sorry. Yeah, you can see this is how it looks in the monitoring world. GPU utilization, GPU memory utilization, GPU clock speed. You can see there are many parameters and you can correlate with the application performance, vector database performance, and what is the GPU, how the GPU is behaving in that, what is the GPU temperature, or how much tokens are used for by a particular application. So this is how we gather all the information. So this is one more screenshot again. Same thing mostly. This is like sample demo. Again, how many tokens? In this case, you can see there are total 15 million prompts which are used. Total tokens used. So all that information will come here. This is where the browser real monitoring. A customer can log into. This is where I spend my time day to day. I user experience monitoring. You can easily see in this application, demo application, end user monitoring response distribution, end user response time trend, from which all browser the requests are coming, from which countries how many requests are coming. So this is how it helps the customer to, and you can see on the left hand side, page requests, Ajax requests, synthetic monitoring. This is for the mobile real user monitoring. We can see these are the page mobile device is calling, or mobile rather app is calling. The important piece is here you can see the customers can easily see, okay, which model the request is coming from. Nexus, Kindle Fire, Nexus, Galaxy Nexus, or Kindle Fire. What are those devices, Google, Amazon, and which version of the Android is used. What was the status code written at that time. So all this information is available in a monitoring tool, like Splunk and App Dynamics or other. This is a crash report details, like from by operating system, on which operating system, how many crashes are happening, on which devices, on what are the carriers, meaning ATT, Vodafone, Airtel. All that information is available out of the box in our observability and monitoring tool. So this is the way it helps the customer to monitor their health of the end user devices and websites. And this is where I'm trying to show the correlation to you. Even though the cart API is called, it is going to which cart API. This is a cart page, you can see www.ecommerce.com/cart, and from which device it has originated, Android, which version, where, what type of network was used, 5G, 4G, and business transaction, meaning what is the backend service which is used. So this is the correlation. And this is the user journey map, meaning customer went to ecommerce.com store. From there, he went to some other page. How much is the drop percentage? You can see here 3% request has been dropped. All that information we show as graphically also in our monitoring tool. And this is the backend service. Let's say one of the backend service, or 3 or 4 backend services which are talking to database, MySQL, or ActiveMQ. So they can graphically also see the currently information is flowing between the apps or not. And these are some of the platforms which are available for observability and monitoring: Splunk, Holy Cloud, and App Dynamics. This is where I work day to day. And these are some of our competitors: Datadog, New Relic, AWS CloudWatch, Grafana, and ELK Stack. And this is one slide I just added just for you to understand AI for developer productivity. It's not just about AI using the AI for doing the actual work, meaning in actual workloads. It's about how can we utilize the AI for the developer productivity, meaning day to day we are already using the AI for self onboarding and knowledge building. What that means is companies have very huge code bases. Now, how do I learn that about that code bases? And I can ask any question related to code. So that is where it is very helpful, and we have started using it for self onboarding and knowledge building. We can also utilize, we can give more context to the AI by writing a good prompt. Meaning, when I say good prompt, the definition of good prompt is providing the more context. We can build the actual features also. We are able to do some code refactoring, and a lot of companies are using for generating the unit test cases, and also are working on see if we can do the auto upgrades. And there are a lot of vulnerabilities which are part of, you can see the third party packages generally we use. So to fix that also, developers are using AI. And these are some of the popular tools. Cursor AI, this is what we are using, or at least is my favorite. Cursor AI, I'm using extensively the Cursor AI. Windsurf, GitHub Copilot, even up to some extent we use Copilot, even Windsurf. And this is a website where you can see if there is an AI for that or not. You can just go to this website. All these links are available. You can just click on it. And this might be, you are already aware, Perplexity, ChatGPT, and FindAI. FindAI is basically, it can create diagrams also along with the text automatically. So the the idea here I'm trying to give is, it is very heavily used for even the developer productivity in a day-to-day life. So it is better we learn these tools. And these are some of the references. You can go through them offline. If you want to learn about how to build an MCP server from start, I have provided the links. And if you want to do any AWS training, Azure training, all the information is available here. You can go through them, or how can we build an AI agent from beginners, for beginners. Okay, so this is what I had, everyone. I hope it was helpful, and I'm open for any questions and answers. Maybe I have went 5 minutes or 7 minutes more on time, but sorry. Yeah.
Just a minute, sir. Students, if you have any questions related to AWS architecture, Kubernetes, multi-cloud or observability, please feel free to ask. You can either type your questions in the chat or raise your hands or speak. Sir, we are actually lagging on YouTube. That's why they are not able to ask any questions. Yes, sir. We're done from our side, sir. Okay, sir. On behalf of Pimpri Chinchwad University, School of Engineering and Technology, I sincerely thank you for our guest speaker, Mr. Mahesh, sir, for sharing his valuable time and knowledge with us today. Sir, your insights into container explanation, how Kubernetes fits into AWS architectures, how to effectively manage deployments across the multi-cloud environments were especially valuable. Your detailed explanations on how to architect scalable solutions on AWS, manage Kubernetes across multi-cloud environments, and implement effective observability and monitoring practices were truly valuable. Your talk gave us practical ideas, real-life experiences, and inspirations that will surely help our students and faculty in their learning journey. I would like to thank our Pro-Vice Chancellor, Dr. Sudeep, sir, our Dean, Dr. Vijay, sir, and our HOD, Dr. Sagar Pande, sir. A big thanks to all our teachers, students, and participants for session successful. With this, We happily close day 3 of AI Project Bootcamp and look forward to meet you again in the next session. Thank you so much, sir.
Thank you, everyone. Thanks for giving me the opportunity to share my knowledge and experience. I thoroughly enjoyed it. It was a very good experience for me. Thank you so much.
Sir, maybe you receive questions on YouTube link, sir, which I have already shared. You can ask
Sure.
there.
Okay, so let me go to.
Can you check once?
Yeah, yeah, sure. I think there is some delay, but
Yes, sir. Yes, sir. That is
that
delay,
question,
sir.
I tried to read that question. I did not understand what is Versal. Can somebody who is asking can come online and
Okay, Universal Reviewer. Sir, how is Versal for project deployment? Can you ask?
what is Versal? Can somebody explain me first? What do you mean by Versal? Is there a tool called as Versal? Okay, we are not using a Versal, so I won't be able to comment on that. What we use is Harness and Jenkins for deployment.
Thank you, Sudhir, sir. Yes, sir. Thank you so much, sir. Thank you.
Okay, thanks everyone.